Welcome to this week's lab. In this lab, we're doing an elimination reaction, or the dehydration of cyclohexanol to cyclohexene. Here's the overall reaction scheme. So we take our cyclohexanol, react it with phosphoric acid to get cyclohexene and water as the byproduct. I've posted the rubric for the lab, which you should look at. I've also posted the readings from the textbook, which you should look at, and that covers the mechanism as well. We're varying the experimental significantly from the way it's written in the textbook and even the way it's written in the lab manual. So it's important that you look at this video for clarification on what we're actually doing. So the mechanism, I have an alcohol in the presence of an acid. It's a secondary alcohol. So the first step of this mechanism, the alcohol is going to react with the H+. And this, like most organic reactions, is going to be an equilibrium reaction to give me the protonated form of cyclohexanol, where I now have 2 hydrogens on here. So this is starting to look a little bit like water. The H2O, it's still attached to the cyclohexane ring, and in the next step, we are going to eliminate that water. So this elimination step, this is a E1 mechanism. So it's unimolecular. Right. And the products of that bond cleavage are going to be the secondary carbocation and water. Okay. Now, one of the hydrogens gets eliminated. Again, some things that you would have learned in lecture about this. We always eliminate to form the most stable alkene, or the most substituted alkene. So that's something you should think about. That elimination is going to give us the cyclohexene. Plus it'll regenerate our catalyst, H3O+, which is really just acid and water, which we're going to have. So the phosphoric acid acts as a catalyst for this reaction, and the water generated acts as a nucleophile to do the elimination. All right, so having gone through the mechanism, we can see how this reaction takes place. Let's talk about what we're going to do in the lab. So the first thing we're going to do is weigh out 4 grams of cyclohexanol. And please, this does not have to be exactly 4 grams of cyclohexanol. What I see is too many people spending too much time at the balance trying to get exactly 4.00. We just need to be close to 4. If it's 4.1, 3.9, it really doesn't matter. You're just going to keep on adding it until we get somewhere close to 4 grams. The exact mass that you get is important, and you need to write that down. So you need to write down your exact mass for this, whatever you actually wind up weighing. Whether it's a little bit over 4 or a little bit under, doesn't matter. The phosphoric acid, since it's a catalyst, the amount's not critical. We're adding 1 milliliter or 20 drops. And that's how you should weigh it. That's going to be measured out in the fume hood. Now we're going to heat it to distill the product. So the heat helps the elimination reaction take place, as well as distill out the cyclohexene that we're going to make from this reaction. We're going to collect that distillate in a pre-weighed container. Again, the pre-weighed container is highlighted. You have to get an accurate mass of this container so we can calculate by difference how much cyclohexene we collect. This will be the crude weight. Right? This is the crude material before we actually do anything to it. There's going to be some water present in this that we have to take care of. There might be some acid in it, but hopefully not. And there potentially could be some cyclohexanol, but it's highly unlikely that cyclohexanol will make it up the distillation column. All right, so with this crude product, we're actually going to get a weight of it. Make sure you record the mass after you collect it. Then we're going to treat this with brine. So this is really just a saturated sodium chloride solution. And what's going to happen is the sodium chloride solution is going to go to the bottom of that flask. Okay, all right. We're going to remove that brine with a pipette. So we're going to have some kind of a container. There's going to be the cyclohexene at the top, and you should see a ball of the brine at the bottom. We're just going to stick a pipette in there and suck up this brine. So this will be the cyclohexene, which will be on top, and then your brine, which we're not going to add a ton of. We're going to suck up with a pipette. Make sure we don't take any of the cyclohexene with it. That's how we're going to do the physical separation. Instead of using a separatory funnel, we'll do it this way. If we wind up having difficulty doing this separation with a pipette, we may switch and use a separatory funnel, and we'll talk about that when we get to it in the lab. Okay, then we're going to throw in some drying agent. Not a ton of drying agent. I don't know which drying agent they're going to leave out. Some of the common ones that we've used, sodium sulfate, that's an easy one to filter from, so I'm hoping we have that present. Or the other drying agent is magnesium sulfate. All right. Then, after we've dried it, so we'll have our cyclohexene with the drying agent. I'll just draw the structure of cyclohexene. We'll have the solid drying agent on the bottom. We are going to decant. That means to pour out. We're going to pour out the cyclohexene, again, into a pre-weighed container. And then we are going to weigh it. If we know the mass, this will be our purified material. And we can compare how much we lost from the crude material to the purified material. From this, we're going to calculate a percent yield. That percent yield is based on how much you start with. That's why the number that you actually record is the important part. We convert that to moles. We should make the same number of moles of cyclohexene. We can convert that to grams of cyclohexene, and we can compare the actual to the theoretical and calculate. So we're going to calculate the percent yield. From that, we're also going to get an IR of the product as well as the starting material as confirmation that we've actually made the correct material, and a test to the purity of the material to make sure we don't have any of the alcohol present in it. Okay, some of the lab equipment. I'm not exactly sure what we're going to have out for this, but I assume we're doing the reaction in a round bottom flask. So this is your round bottom flask. You're going to weigh out the 4 grams in this. What you're going to need to do on the balance is you're going to have some kind of a stand to put that on. So we're going to have some kind of way of balancing the round bottom flask on the surface of the balance as we add our stuff to it. All right, so we'll talk about that when we get to the lab. You're going to have some kind of distillation column. All right, so this is your distillation column, round bottom flask. And this will be some kind of distillation column. Might not look exactly like this, but we need some distance to provide ample time for heating of the material, have it go up, and make sure that we're only distilling out the cyclohexene. We're going to have some kind of a condenser. This is going to cool the distillate and have it go into the liquid phase, and we're going to collect it in some kind of a container. And remember, this container is going to be pre-weighed. We're going to know the mass of it we're going to know the mass of it after we collect our distillate, and we're going to calculate how much we're going to have. I'm not sure what kind of a container we're going to have. It might be another round bottom flask. We may be able to use just a vial for this. Right? So the entire setup should look something like this. What I want to stress in setting this up, your flask must be secured with a clamp. Right? We're going to provide heat at the bottom of this, and ideally we should use a jack to lift up the heating mantle to our round bottom flask, because we need a way of lowering it. We are not distilling this to dryness. We're going to make sure that we leave about a milliliter left over. Hopefully that'll be the phosphoric acid that's going to be present in that. That'll just be left behind. The distillate is going to go up. There's mention of this copper insert. I am positive that they are not going to have the copper insert. So we're just going to have some kind of distillation column, some kind of head for the column. It might be attached, it might not. These are called Claisen heads. Right? We may or may not have a thermometer on it to record the temperature. This might just be stoppered. And then it's going to go into the condenser. We have to hook up the condenser where the water comes in at the bottom and goes out at the top. Right? That will fill up this jacketed condenser, right, with water and allow it to cool. We may or may not have an arm attached to it. We may distill right into the open container. Again, I have to see what they leave for us, and then this will be our container that we collect the material in. Okay, some safety issues. The distillation setup has to be secure. We can't have wobbly, we can't have any stress being placed on any of the joints, and we have to make sure that all the joints are closed. We can't have loose connections, or we're going to lose all our material from the distillation out these openings in the distillation. A lot of times we have these little clamps, which kind of look something like this. They're yellowish, and they kind of clamp right on to the, they kind of look something like this. And there's a top piece that's smaller than the bottom piece, and we can connect the glassware together at the joints through that. Inspect the glassware, make sure that there are no sharp edges, not necessarily meaning we're not going to use it, but I just want you to be conscious of it to make sure that you're not going to risk cutting yourself on any of those sharp edges. All the organics, other than the time we weigh, should stay in the fume hood. Right? Keep your pipettes vertical. This is still something that you're getting used to. Your pipette has to be straight up and down, or else we risk having everything go into the pipette bulb. Right? We don't want to contaminate the pipette bulb, so this should stay as vertical as possible, straight up and down. Okay? The phosphoric acid, very corrosive. Make sure that you don't get it on yourself. Make sure you're careful when you're doing it. It will destroy the pipette bulb and the cotton that's in this if you're not careful. It's very important that you keep your pipette bulb vertical, especially with the phosphoric acid. Okay? The cyclohexene that we generate is much more flammable than the cyclohexanol. It's more volatile. Make sure you look up the boiling points of both of these compounds. They're written out in the textbook. All right. And that's pretty much it. If we have any questions as we're doing it, of course, I'm there to answer them. And hopefully we'll have a nice, productive, and quick lab.